Hello AP Physics students, this is Dr. Brenzi, and this is a video about formative 8.1 problem number 1, and this one stirred up a lot of controversy because a lot of people calculated that the answer is C, but I'm going to use this video to show why the answer is B, and that my key was indeed correct. And by the way, thank you for those of you who were concerned and kept on trying and still getting C, but I'm convinced it's B, and I'm going to show you why in this video. So we have a swimming pool that measures 5 meters long by 4 meters wide by 3 meters deep, and we want to compute the force exerted by the water against the bottom of the pool. A lot of you recognize that in order to calculate the force exerted by the water against the bottom of the pool, we have to calculate the pressure at the bottom of the pool. So let me draw a diagram. Here is our pool, and just label some dimensions here. This is we're going to call this the Z direction. Okay, and it goes from 0 up to 3 because the water's 3 meters deep. And then we have a length of 5 and a width of 4 meters for our pool. Now let's write the formula that gives us pressure versus depth. And I'm going to write the differential form of it. So dP equals negative rho times G times dZ. So as we go, what this formula says is that as we go up in Z, our pressure actually should go down, and vice versa. When Z decreases, our pressure should increase. Okay, if I integrate both sides of this equation and I take definite integrals on both sides, what I'm going to get is the integral of dP equals the integral of negative rho g dz. And I want to integrate from 0 to 3 in depth, and I want to integrate from P of 0, whatever this pressure is at the bottom, to P of 3 at the top. So on my left-hand side, that integral is P of 3 minus P of 0, of course, and then the right-hand side is negative rho times G times 3 minus 0. Okay, well, those of you who decided to not use the integral form, when you wrote this equation, delta P equals negative rho G delta Z, which was perfectly legitimate for you to do when the height difference is small, which it is, then you also would come up with something like this if you did delta P. That's obviously delta P, and obviously this is delta Z. Okay, so I am interested in figuring out, actually I did a little algebra there, but I think that was pretty obvious. I am actually looking for P of 0. I want to know the pressure at the bottom of the pool, right? So I'm going to go ahead and solve this for P of 0. And so I get P of 0 equals 3 rho G times P of 3. And I know that rho for water is 1,000 kilograms per cubic meter, and I know that G is 9.8, so I end up with this. And then if I now this is where we ended up. This is where we went astray. Okay. Everybody was actually thinking that just this by itself is P of 0. And then you were doing the same thing that I was doing, and you were all assuming that the pressure at the top of the fluid is 0. Well, that's not true. The pressure at the top of the fluid is actually atmospheric pressure. Okay, so what you had to do to enter for P of 3 is actually 1 atmosphere of pressure. When you do that, you're going to get P of 0 equals this. So you're going to get P of 0 equals 1.29 times 10 to the 5th pascals. A lot of you got this for your pressure at the bottom of the pool, just this part. And then when you end up multiplying that times the area, which is 20, you all ended up with this answer choice right here. But this is actually the pressure at the bottom of the pool. And when you multiply that by 20, you get the force, which is 2.6 times 10 to the 6 newtons. So the correct answer really was B. All right, I hope this helps you guys out for preparing for the summative on Monday. And if you have any questions, feel free to zip me an email, or you can give me a message on Edmodo as well. All right, I look forward to seeing you on Monday, and happy studying. Bye.